get everything we need.
Pay no attention to the man behind the curtain. This is for an upcoming video. The only sneak peek you'll get out of me today. So here's the skinny. It's winter here in Baltimore and it's not very optimal spray painting weather. So what I've done is in an unfinished side of my basement, I've just set up a little spray booth. That's it. A little ventilation going outside. I spray over here. It shields me off from the fumes in my office. No one else in the house can smell it. It's worked out really well. The helmet's not the focus of this video. It's just I'd like to bundle work that I'm doing together for future projects. So now don't worry, I am in a well-ventilated area. Again, as I said, I have ventilation going outside, and I'm also wearing a respirator. These are aerosols. They're very toxic. You should do your best to protect yourself from the fumes, from the particulates, all of that. I also wanted to take a few seconds to point out a few things. Now, if you notice, the faceplate is ridiculously smooth. Now, this was printed by some of my buddies over at Additive America. I'll link their business down below. This was printed on an HP multi-jet format printer, and it was an amazing print. Now, beneath that, the actual focus of our project today is the arc reactor. This was printed on a large format FDM machine. It's an older machine, it's less used. I pretty much just keep up with some of the maintenance on it, and it's not particularly made for detail. I could fix that, but it works for most of what I'm doing, which is the Iron Man helmets. And it will absolutely come up. If you notice, the surface quality on this print was garbage, absolute garbage. That's mostly my fault. I got sloppy and I just kind of wanted to get it printed. And it goes to a belief of mine that there's no failed prints when you're using thermoplastics, because I can always melt sand, Bondo, filler primer like we're doing here. It makes it easier to work from perfect prints, but you're not always going to get a perfect print, and you shouldn't get disheartened. And you'll see me finish a lot of really messed up prints. Before getting into digital, I was a fine artist. I still do a lot of fine arty kind of things. And for me, working with molten thermoplastic to repair messed up prints, it's a form of therapy, a form of sculpture for me. That doesn't mean you have to do it. You can absolutely just reprint it. You can always just reprint it. And you'll see, in a future video, I'm going to show you one of my most messed up prints, and we're going to salvage it. After that layer of filler primer, you really get to see what you're working with. This print is horrendous, but we're gonna work through it. I also wasn't sure what I wanted to do with the internals until I started browsing Adafruit. Now, Adafruit is a site that you can get all kinds of engineering components and parts and pieces, and I found these 45 by 86 millimeter backlit panels, and these are just the backlights you would see behind, a normal LED display, and I just thought this might work. The biggest part will be whether or not I can modify it to fit within the existing printed enclosure. We will see. We're gonna need to run to the printer to make a few more pieces. So I got these files from a designer on Thingiverse named R2Droid2. And to start, I only printed off 2 of the files because I thought I'd only use the top and bottom. So here we're going to print a template for the acrylic back panel as well as the electronics plate, which I'll get more into later.
So these are the parts I was working on yesterday. There were a few additional parts that I hadn't printed because I didn't think I was going to use them. But once I reviewed the makeup of this again, I decided that I would. So this is the plate that holds the electronics. Originally I was just going to have them in here behind the diffused piece of acrylic, but now I think I am going to use this. And this plate sits on top of what I printed yesterday. And then this is a template that I'm going to use to cut out the piece. I was going to cut it with the laser, and that part's going to go in there. There's a few spots. I'm not entirely sure what these spots were designed for. I might use them for strapping, or I might use them to. I might just fill them. Actually, now that I look at it, I might just fill it.
Now we're gonna jump over into Illustrator, this isn't a program I use very often. If I get more in depth than just the surface, you're gonna be able to call me on it. So we're just gonna keep it pretty superficial. I needed to make a template for my buddy's Glowforge, which we're gonna use to laser cut the acrylic. As you can see in the reference image here, I may have tried to cut it by hand with an X-Acto knife. Not exactly the best tool for it. My bad. So to start, all I'm doing is tracing the shape out. I'm going to connect the edges, and then I'm going to reflect that over to the opposite side to make the full shape. And I'll need this solid line in order to run the cut operation on the Glowforge. So we're going to do an edge, and then we're going to do a cut from the sheet. I'm not going to do the cut from this broken piece. I'm just going to flip it around, use the good side. But here you just see me connecting those edges to make sure it's one uniform shape. Pretty simple. Next, I duplicate that over because I'm going to use that as the boundary box for this pattern that I'm going to make. If you know an easier way to do patterns like this in Illustrator, please drop that in the comments below. I just kind of winged it. I probably could have did some sort of rotational pattern. In a future video, we're probably going to use a very similar technique to make lenses for the other Iron Man helmets. It's something I've been planning out this week. But for now, we're just going to go here. And again, you see me just using Ctrl-J to connect those edges. I don't know what the MacBook shortcut would be. And I'm really just going to do this by hand. I'm going to get them in about the right position, copy them. I'm going to copy that group, reflect it down to the bottom. I have in my mind the triangular tech pattern that I want to use, and between the distribute tools and just some hand adjustments, we're going to work it out. Again, I am no Illustrator guru. If you know a better way to do the thing that I'm trying to accomplish here, please let me know in the comments so that I can share it with people. We can get that out there. What I ended up doing was I aligned all these parts, duplicated them several times, and made a bunch of rows, and then I just duplicated it and moved it again. I'm pretty sure there, or at least in my mind, there should exist some sort of patterning tool where I fill a boundary box with this shape. We'll get there. Not in this video, but we will get there. In the end, how I ended up working it out was I did I guess you can consider it a Boolean. I did a subtraction of the line from the pattern that I made. And I tried a couple times until I got something I was satisfied with. And I knew this was going to be the diffuser acrylic panel, so I was kind of okay with the way it came out. I could have put a little more effort into getting the pattern perfectly aligned with the boundary, but that's for next time. That is for next time. Is that the cut and the etch commands are powered by SVG files, and so I ended up having to make two separate ones to input into the Glowforge to one do this pattern etch and then follow it with a cut. And you always want to do the cut last, because what happens is in the machine, if you do the cut first, the material drops from that initial housing and it might misalign the etch. Before we set some stuff on fire with the laser, I just wanted to make sure everything fit. So from Illustrator, I printed out a 1:1 scale of the pattern that we just made, checked it against my 3D print, everything worked out, cut it out very meticulously across the lines as they taught me in elementary school. Who am I kidding? I never learned how to color in the lines. But everything fit. So I was very optimistic at this point. And then I noticed that I might actually be able to take this to also cut the lights. We will see. But we're going to take the electronics tray, check my sanding. Yep, did a good job. We're going to drop this into our light housing template, and we're going to stick this backing on there just for illustration and hold it in there. And if we do everything right, this is about what we're going to get at the end. If I'm happy, you're happy. Let's go. Let's take this to the laser and burn it. Safely etch it under adult supervision. And here's what that interface looks like. Ignore the other parts because those, again, are for another video. Now, the Glowforge does some amazing work. If you notice on some of the smaller pieces, there was some burning from the laser. I could have dropped the intensity for the thinness of this material, but it came out immaculate. At this point, everything's really starting to take shape. I've been cleaning up the print as we go. We have our laser cut acrylic backing, and this thing came out way better than I can imagine. Because of the heat, there was some slight bowing in it, but that'll be rectified once we put in the internals. But again, look at this. Look at the way it etched this pattern. I couldn't be too much happier with this. And once we get everything together, it's really going to set it off. I mean, come on now. Look at this thing. For reference, if I was not afraid of getting a takedown notice, we would definitely be blasting Kanye West Can't Tell Me Nothing. So, a friend of mine gave me a bunch of these little lights a while back, and I used one for an Iron Man gauntlet, and I had the other one laying around. But what I enjoy is it's a whole circuit with this nice little clicky switch button. We're going to repurpose some electronics, so let's see what we can do. To use these with our Adafruit components, we're going to need to make a little USB slot in the bottom of this plate. And then off camera, I took my Dremel and I put a cutter bit in it, and I traced out a pattern onto those acrylic panels, and I ended up cutting out the shape that I needed to go into the housing. Also making sure that I remembered which contacts are positive and negative and how I'm going to run them. Next up, I'm going to be taking this piece apart in order to utilize it, but first I'd like to take pictures or video to remember where exactly each particular part leads. That helps me reuse it later. Now on an LED light, there's usually a long and a short lead, and this usually dictates the polarity. On mine, the longer leads were positive and the short ones were the negative. And this is important to remember as I start to wire these. And here's where I might have went wrong. I decided to do these LEDs in parallel instead of series. And I'll do a longer video explaining the difference, but I was worried about doing them in series because if one failed, the circuit would fail. And it's a lesson I learned when I was building a Star-Lord helmet. So I got the hole just about the size I needed. I got the light cleaned up. I got the circuit and the switch just about transferred over. And I have my power boost, which will be used to recharge this entire system, li-poly battery and all. And it's a 2500 milliamp hour li-poly battery, so it should last a while. And man, let me tell you, there's no better feeling than when the vision you had starts to come together and you have everything laid out, and then things go horribly wrong. We're gonna go back to my office and I'll illustrate the problem that has arisen.
It's nanotech. You like it?
So here's where I messed up. While cutting and testing everything and some of the electrical wiring, I shorted one of the LED panels. I did not put a resistor in that circuit and I messed up. It looks gorgeous though, but I messed up. Back to the drawing board. So as I was leaving to go back to the office, my wife sent me my honey-do list, and part of it was to stop at Walmart. Now, while in Walmart, I found this circular LED light. It was in the clearance section for like $1, and I immediately knew I have an idea. I won't bore you with too much of this, but here was my thought process. I found this LED light. It was $1. It had a circular pattern, which I thought I really enjoyed the acrylic panels that I had gotten, and even if I couldn't get the LED use out of them, I still had these really nice, already cut acrylic pieces. I had hot glued it to the backing plate and lined it with silver tape, and I realized I was gonna have to undo all that, so I did. I sanded them to be a little more diffuse, and I tested tested out the brightness of this light. Now it ran on 3 AAA batteries. That's like what, 3.7-ish volts. The power boost that I was using in my previous circuit upscaled 3.7 to 5 volts. So I had a good feeling that this would work. And I began disassembling those acrylic panels. I just wanted to test the look before I made any crazy decisions. And it really worked out. It worked out better than I imagined. What I decided to do was sand it a little bit in order to see how well it diffused the light after sanding. It didn't really increase it as much as I wanted to. I contemplated taking it back to the laser and just sanding it and polishing it back clear and then using the laser to re-etch that pattern I did in the first acrylic. But I just thought that was too much. And now we get to my absolute favorite part, if you couldn't tell, of most of this, and it's stripping out some components. Now this little LED light came with a reflector ring, it had its own little clear acrylic diffuser. It worked out pretty well, and I actually thought about including all of that inside, but the more I looked at the components from there, the more I realized that it was going to be way too bulky for what I had put together. So here I'm just going to take the positive and negative leads. I always try to mark my leads when I'm doing things like this so I don't forget later, because that's not particularly dangerous in some instances, especially if you're using like non-controlled LED lights. Like, these just need power, they don't need any sort of code. And I also started to realize here that the acrylic diffuser plate was going to infringe on this new design that I was working out in my head, because at this point we're off the rails, guys. We're making it up as we go along. I'm gonna try not to bore you with too many of the details, but here I'm just taking apart that assembly that we got and I'm fitting it into the enclosure that we printed and sanded. Nothing spectacular. It's mostly a balance of what I want to go where and how I want it to function at the end. At this point, I'm fairly certain of how I want to assemble this. We're going to have that push button mechanism come up from behind the light, as opposed to my original plan, which was to have the push button on the inside of the casing that would be against my chest. And this way I'll be able to press the center acrylic in order to activate the light, keeping the system as contained to the arc reactor enclosure as possible, with no external wires or battery packs. So this actually came out a lot better than I originally envisioned. As opposed to having that push button on the outside, we have it on the inside, and I'm securing the enclosure with a few screws. So that way if I ever need to replace any of the internals, I still have to fill these holes. We're gonna get those filled up, and that's about it. Now ideally, I can take this acrylic, I still need to sand it some more to further make it a better diffuser, or I might have to find a new diffusion material. But we take these two, we assemble them in our top, and if everything works the way I imagined, then we should be able to close this together. Okay. Yes, it's working, but it's not flush. There's a considerable gap here. I might need some time to think about how I want to address this. I might have to lose this internal acrylic backing plate. Okay, so here's the skinny. I'm gonna do some more surface work to the outside casing of this. We're gonna get it all nice, polished up, get the edges all nice and crisp, and we're gonna work out that gap. I have a buddy, I might get some engineering grade rubber gasket from him. We use some for a project at work, we might still have some. If so, I really think that'll help with this project. In the meantime, I'm going to leave you here, let you guys know what to do. Like, subscribe, comment below with a project that you want to see us tackle in the future. And when we get back, I'm going to cover the rest of the finishing of this, the painting, the weathering, and we're going to look at the final product. So, take care, and I'll catch you guys soon. Peace.